Okay, so this is question number 1. We have this quartic that has 4 factors, discrete if A are particular values, but for some particular values, some of these will double up. So, in terms of A, we're required to state the values for which is equal to 0. So, x is going to equal -1 or negative A or 2 or 2A. And that's going to be the 4 answers that will give f of x equaling 0. Find the values of A, so it's plural, where f of x has exactly 3 x-intercepts. Well, we've got to have x equals -1 and we have to have x equals 2. So I'm looking for another one. Another one can happen is if A equals, okay, so if A equaled 1, that would give me that being the same, but unfortunately it give me that being the same, and that would give me 2. So I can't equal 1. If A equaled 0, then that would be a 0, that would be a 0, and the other 2. So A equals 0 is one of the answers I want. If A equaled -2, if A equaled -2, then these two would be the same, that would be different, and this one would be different. So A could equal -2. And if A equaled -1/2, at -1/2, this one would be the same as 1, and then -1/2, so -1/2, and that counts all of the factors equaling one of the others, so those 3 answers. Exactly 4 will be A can be absolutely anything except the following numbers. -1/2, because that gives me 3, -2, because that gives me 3, 0, because that gives me 3, and 1, because that gives me 2. Okay, so they're the answers for A and B. Over the page. Let the function g, so to find the derivative when A is 1. Okay then, so if I come to bring up the main keyboard, let's type that in, bracket x plus 1 squared, open bracket x minus 2 squared, double check it, that's correct, and we're looking for the derivative. Calculate derivative, first derivative, okay, and that gives me, that equals 4x cubed minus 6x squared minus 6x plus 4. Find the coordinates of the local maximum of G. The local maximum of G. There's only one local maximum of G and it's up there. Analysis, G solve max, and it's at 1/2 and that value. So it's 1 mark, 1/2 and 5.0625, which is exact by the way. Or if I want to turn that into an exact value, pick that up, that there, press execute, or I could write 1/2, 81/16. Find the values of x for which the derivative is bigger than 0. Therefore, there is a positive gradient, and I can see there's a positive gradient between here and past there. So I think that we're going for -1 to 1/2, non-inclusive, union with, and that's 2 to infinity. And that's when the derivative is going to be positive. I could take this and make it bigger than 0, so keyboard, maths 3, bigger than 0, and solve for x. And that's going to give me the same intervals, -1 to 1/2 and bigger than 2. Consider the two tangents at these points. Determine the coordinates of the points of intersection of the two tangents. Okay, so I'm going to have tangent 1, where that's x1, and tangent 2, where that's x2. So if I grab my original expression and I copy that, come down and paste, I'm looking for the tangent line. Calculate line, tan line, and that's going to be at bracket negative root 3, close bracket, plus 1, close the bracket, divided by 2. And that gives me, that particular tangent line. And if I pick this up, and the second one is where that's positive. And that gives me that particular tan line, and we're looking for the points of intersection. So that equals this tan line and to solve for x. And I get x equals a half. And I will just take one of these lines, that tan line there, copy it, come down, paste, math 3, given x equals a half, take all of it, brackets and all, doesn't matter. Simplify that answer, I get 27 on 4. It's worth 2 marks. So I did tan line to, what's our function called? G of x. Tan line to G of x at x1 equals tan line of to G of x at x2, x equals a half, therefore there is my answer. Over the page. So what have we got? Let G remain this, where A is 1. Okay, so what does G of x look like? I didn't go all the way down. So G of x looks like, that is G of x. And this other one, and the other one looks like this. So it has a turning point of 4. So I'm looking at h of x. H of x has at 4, 0, and translations only that takes h to g, and we know from over the page, g has one at a half and 81 on 16. So you want to go from 0, 4 to a half 81 on 16, which is 5.0625. Therefore, you want to move this way a half. Therefore, translate a half to the right. And you want to then move from 4 up to 5. So then translate 1.0625 up, which is the same as 17 on 6. Okay. Using dilations and translations, describe a series of that will have both local minimums at the same coordinates of G. Okay, so looking at G, G's got local minimums at -1, and 2. And this other one has local minimums at analysis G sol minimum at that value and negative 9 on 4, and that value will be that is this one. So if I'm looking for the derivative of that and set it equal to 0 and solve for x, and I've got negative root 10 on 2 to positive root 10 on 2 and negative 9 on 4. So I've got to do dilations and translations. Okay, and I've got to take H2G. So I've got to take this one and make it this. Okay, so at the moment, to do the dilations, I wish to dilate this in, because at the moment we're going from minus root 10 on 2 to, so we're going across a total distance of root 10, and I want to go a total distance of 3, and 3 squared is 9, so root 10 is bigger than 9, so I need to dilate. And I need to dilate by a factor of, I want to divide by root 10 to make the difference 1, then I want to multiply by 3. So I want to do dilation by a factor of from the y-axis, and because I want to reduce it to this, my dilation has to be 3 on root 10. Then when I'm in that position, so I will then be at 1 times 3, so the value divided by the, this times 3 divided by root 10, I'm at negative 1.5. Okay, so then that will give me negative 1.5. So I want a translation to the right, a half a unit. And then I need to go translation up 9 on 4, and that's right. And that's the question, question 1.